Okay, we're on page 8. Let me remind you what the heck we did. Guys, I saw you Monday for 25 minutes. I'm seeing you Wednesday. I'm seeing you Thursday. And then I won't see you again until Wednesday. Gifts. You know what I'm saying? So let's remind ourselves what we did on Monday. If it says find the particular solution, you guys, all that's saying is go find the function that has that slope. And then they're saying this function is going to go through that point. Let's first just figure out what function has that slope. The first thing we got to do is go ahead and separate those variables, people. Are you cool if we multiply both sides by dx? Well, we'd have dy is 4x dx. That is still just saying my slope is 4x, right? Then you guys, we got to go, if they started with the slope and they want the function, we got to go find the antiderivative. Whose derivative is 1 with respect to a variable of y? The derivative of y would be 1. Very good, Greer. Whose derivative is 4x with respect to an x? Yeah, it would be 4x to the second over 2, right? So that would just get me a 2x squared. What did I leave off here? Thanks, Care Bear. Okay. You guys, would you agree if I back this up? Is the derivative of y dy dx? If I'm like checking my work, is the derivative of 2x squared 4x? It's the derivative of a constant 0. So I know I found the right antiderivative. So I know that this function has that slope. So they said find not just the general form, this would be the general form. They said find the particular solution that not only has that slope, but also goes through that point. What could I do to go figure out what my C would be? Plug it in. My y is 7 and my x is 1. Daisy, what were you going to say, bud?
Never mind.
8. What's my constant, y'all? 5. So what's going to be the equation that not only has that slope, but also goes through that point? Y equals 2x squared plus 5. Okay, here we go. That one he said was light. I agree. This one's a little heavier, if you will. What is the antiderivative? Sorry, separate these variables. What are we going to have for separating those variables?
Bad, then it's over.
Y dy equals x plus 1 dx star. Is that what you said? So now you just separated the variables. You got 1 point. Go take antiderivatives now. Antiderivative of y. Beautiful. Y squared over 2. Antiderivative of x. Antiderivative of 1. Plus. Beautiful. And let me just say this one more time. This was still dy dx. If they want the function, we got to take an antiderivative of the slope to get the function. Let's go plug in our point now, you guys. My y is -2, my x is 0. If I plug in a -2 right here, it's going to be positive what? 2. Equals, my x is 0.
0 plus 0.
Right. You were cool with saying my constant's going to be 2? Yeah. You guys, we're going to plug that right back. Right there. So we got y squared over 2 is x squared over 2 plus an x plus a 2. You guys, they always say find the particular solution y equals. They want my y by itself. We can start going to get y by itself. How would we do that? Love it. Let's go multiply by 2. Boop, da-boop, da-boop, da-boop. That's going to get me y squared equals plus 2 times all that. I like that. You could also leave that as y squared equals 2 times all that. Then we just got to square root it. There's a trick on this one, though. Square root. What's the square root of 4?
2.
Plus or minus. I'm actually just going to leave a blank here. I have an x squared plus a 2x and a 4. And we should technically have a plus or minus right here. Maybe I'll actually put it in. Think about this. This derivative has to be this, and this point must be true. When I plug in a 0 for x here, would you agree I'm left with the square root of 4?
Yeah.
What does it need to equal? Has to equal -2. So which of these do I have to have? The minus or the negative. Oh, which is so ornery of them. But you guys, they're going to do it to you, and I'm going to show you. They're going to do that to us a couple of times. I love that. Nelson's like, okay, let's separate those variables. We down with a little y dy? Y dy equals x squared dx? Okay, that's still slope. They're saying which function has that slope? How do I work backwards? I'm going to integrate it. That's going to turn into a y blank over blank.
Squared over 2.
Love it. That's going to turn into an x blank over blank. X cubed over 3 plus c. Thanks, Colin. C for Colin. Let's go plug in our point, y'all. Which one's the x, which is the y? My y is -2. Picture this. I know that this is weird that it says y of 3. You guys still just picture that as f of x. We're very used to f of x stuff. This in the parentheses will always be the x. Don't let that y confuse you. So you cool with me plugging in a -2 for my y? That's still going to get me 2 over here. 3 in for my x would get me what right here? 27 over 3 is 9. Very good. What's my constant then? -7. You guys, we go plug my constant back in, and we go get y by itself. So we got a y squared over 2 is an x cubed over 3 minus 7. You got it, girl. Multiply by that denominator of that y. Let's distribute a 2 out. That'd leave me with a y squared, 2x cubed over 3 minus 14. I'm seeing a lot of 2x cubed minus 14 right here and here. What am I noticing in front of them? One's positive, one's negative. That's how they're going to do this to us, Mr. Nels. So what do I have to do to get my y by itself here? Square root. Now, I've got the square root, which should always be a plus or minus. In this case, it needs to be a minus because when I plug in a 3 for my x, when I plug a 3 in here, I'd get 27, 9 times 18 minus 14 is 4. And I need the square root of 4 to get me a -2. So that is going to lead this to be a negative root, which is how they're going to get us.
-2. Oh, I was thinking pi over 2. MB.
MB.
So I got E.
I also got E.
Cosine of pi is there. The x value would be a -1. This would get me a -1. And I'd get -1 is my c. Okay, let's look above. You guys, we got to separate our variables
Okay.
above. How many, what, I could bring my d theta over there, but what about this guy? Do we need to divide him out?
No.
Yes, we do.
Take it one step at a time.
Oh, okay. So you just want to get the d theta gone at first? I'm fine. Okay. You cute. Okay. You guys you're going to take some space, people. So I would start on the left side. So you're saying dy is 4y squared cosine of 2 theta d theta. You guys, we got to get my y's over here.
Can we just divide by 4y?
We could divide by 4y squared. Could I leave the 4 over here, though? Because my whole goal is to get y by itself. I want to bring less with it. Colin, you would not be wrong. We'd still get the same answer, but it'll be easier if we just bring the y over there. So when I divide by that y squared, you cool with writing 1 over y squared dy is 4 cosine of 2 theta d theta. Okay. This is going to be brutal. We're going to earn a break from this. Okay, guys? This is brutal. We got to rewrite this thing.
Y to the -2.
Agreed. This is going to be y to the -2 dy. Guys, I just want to focus on this left side for a second. Just the left side. What's the antiderivative of y to the -2? over.
Negative 1.
Yeah, instead of writing over -1, can we just throw a negative in front of it? Ooh, which is the same as -1 over y. You fancy, sir. I like that. That just makes our life a little easier, right? So we added 1 to my exponent, divided by my new exponent, and then Greer said, let's just go bring that guy down. I like it. This right side is a bear. Say that again. U sub. How many people want to vomit with me just saying U sub? I'm with you. So I'm going to teach you how we don't have to do U sub. We can think about it backwards, and it's going to make our life so much easier. Why would this one require U sub? Because it's got like some chain rule stuff in it, right? If I made my U, what? 2 theta, because that's my inner. What's my derivative of U? It'd be 2, it'd be 2, right? The derivative of 2x is 2, the derivative of 2 theta is 2. Okay, you cool if I separate my variables to say 2 d theta? You okay with that? Do I need a 2 d theta to rewrite this?
You need a 2 to u.
I need a 4 d theta, don't I? Oh, yeah. You're saying, yeah. So you're saying I need a 2 do, and then I'd have a 4 d theta.
Yeah.
You're saying multiply both of these by 2. Therefore, my 4 d theta could be replaced with a what? 2 du. What could I rewrite this as? Cosine of u. Okay, this is like giving us all a little PTSD. It's been a while. So, whose derivative is cosine? Careful, whose derivative is cosine? Is just sine, right? Instead of u, what could I put back in for my u?
2 theta.
2 theta, right? Plus my c. You guys, let's just check ourselves. What's the derivative of this? The derivative of this better get me that. The derivative of this, again, we're not writing this down because it's taking a lot of space. The derivative of this would be 2 sine, derivative of sine? Cosine, leave the angle, times the derivative of the angle. Is that what I started with? Okay, you agree the chain rule made us at this point multiply by a 2. The chain rule made us multiply by 2. Mr. Graham, you said right here, multiply by 2 to get 2 du. In order to do this without u sub, what did I do with that 4?
Divide.
I did the opposite of what chain rule would make me do. You said multiply by the 2 is what chain rule would make me do because I've got an inner of a 2. If you do the opposite of that and divide by that 2, you don't have to go through all that madness. So let's back this up.
Divide and integrate.
Divide and integrate. Exactly. Okay?
Divide by the inner and then integrate.
Exactly. So let's say that I gave you this. Hey, the cosine of, let's say if I said 3 cosine of 3 theta.
Sine.
Sine of
3 theta.
3 theta. It would be the answer. What's the derivative of sine?
Cosine.
Of the angle times the derivative of the angle?
3.
Agreed. So that would be it. Okay. Let's back this up. What if I said just cosine of 4 theta?
1/4.
Yes, 1/4 sine. Oh, now let's just double check it. What's the derivative of this? The derivative of this, if I were to just check it,
Cosine of 4 theta.
is leave the 1/4. Derivative of sine is cosine. Leave the angle. What's the derivative of the angle?
4.
Wouldn't these cancel? And am I left with what I started with?
Yes.
You know what I'm saying? So we had to go through U sub just to learn this process. But you guys, if we can just think, oh, chain rule would make me multiply by 4, do the opposite, divide by that 4, you're done. We dig that. Okay, people, we're here. We're there, and then we got a break. We got a break coming. We got 2 sine of theta, 2. This was our antiderivative.
Plug it in.
We got to go plug in that point. I'm going to get rid of my U sub stuff.
-1.
Right, exactly. Again, that strategy was, I'd have a chain rule of an extra 2. So I'm going to divide by that 2. That 4 divided by that 2 got me that one. Good, Soph. You guys, my y value is going to be what?
-1.
Isn't it going to be 1?
Oh, wait, yeah.
Right here?
It'll be negative.
Oh, touche, people. You're saying when I plug in a 1 right here, we're going to get a -1 over 1? -1 equals 2 sine of 2 times my x is pi over 2 plus a constant. Greer's saying 2 tooths cancel out to a pi.
Yeah.
Pi is here. What's the sign over there? Yeah, the y value is 1. I'm sorry, wow, the y value is 0. So all that's 0. We got my c is -1. You guys, we go get y by itself. Here is, I think my y is in the best condition to do that because it doesn't have any negative exponents. Say that again, girlfriend. Just replace that c with the -1, and I'm left with -1 over y equals 2 sine 2 theta minus 1.
Just flip it.
We got to get my y by itself. Touche. How would you write it, bud?
I just flip it, so just y equals -1 over
Or you can just make the
Right,
sign
but
negative.
we have to, when you say flip it, you're flipping it and dividing it though, right?
You multiply by the y.
Exactly.
Divide by the other side. You can just do
Yeah.
this instead.
Yeah. So here's why that works. When we multiply by we got to get that y out of the denominator, you guys. Here's what I suggest. Multiplying this left side by y, on the right side, do not distribute it because I need to get y by itself. I don't want to have multiple y's, right? I'm going to pull a gram and I'm just going to say y times 2 sine 2 theta minus 1.
Divide -1 by that.
Didn't you just divide by -1?
No, you
No.
divide by the function.
No, you
Right, because my y was in the, no, because the y was in the denominator. I got to get y out of the denominator.
And divided by.
And now we're going to divide by that quantity.
can you just leave your answer?
Yeah, girl, 2 sine of 2 theta minus 1. 2, no, we're done. So my y is, and I want to show what Dice is talking about if that is a shortcut anyone wants to take. So Dicey sees this. He puts his y on top. So Dice, you're a big mental mather.
Well, no,
Here we go. This first one. You guys, if I go to get separate variables here, what would I do?
Get rid of that dx.
Get rid of that dx. He says, throw that dx on the other side. I'm down with that. dy equals 5y squared dx.
So divide by y squared.
Divide by y squared.
Understood.
Chloe and Soph said just divide by the y squared. I like that as opposed to the 5 because we want to bring the least amount of stuff over with the y.
-1 over y.
Ooh! You guys, y to the second on the bottom, if we were to rewrite that as y to the -2, right? Just to help us take in an antiderivative. Okay.
-1 over 5x.
Antiderivative of y to the -2.
Y to the
By
negative
-1.
first.
And then could I throw a negative in front of it?
1 over y.
I love it. -1 over y is really what that is.
Equals 5x.
I'm going to put it that way. -1 over y. That's awesome. Whose derivative is 5 with respect to the variable x?
Plus c.
Beautiful.
Okay.
What's my x and what's my y up here?
X is 0.
Good. F of x. My x is 0. My y is 3.
Y is -1.
-1/3.
I'm going to go plug that -1/3 in right there. And I've got -1 over y equals 5x minus 1/3. What do we do to get y by itself?
Maneuver.
Yes.
Multiply by y.
Multiply
Divide by the function.
by y. Exactly. She said, all right, when I multiply by y, I'm left with a -1. I'm not going to distribute it to that side because she says we're going to have to divide it out. You're so right, Soph. When I divide out that 5x minus 3, which is exactly what Dicey was saying, he's a flip it and divider. We're left with -1 over 5x minus 1/3, which is right, but it is not how they wrote it.
I'm
Can you
noticing
just
that now.
multiply by 3?
So you can put 3 on top.
How would I change a -1 to a +3? Multiply by -3 is a -1 times a -3, 3.
Yeah.
If I gave just Colin that lollipop for being Captain Von Trapp, that's not fair. I got to give everyone a lollipop of multiplying by a -3. When I multiply by that -3, Negative times negative on top got me a 3. Mr. Stevie, you're right. A negative 3 times that 5 is a negative 15x. And a negative times a negative is a positive 1.
Well, why are we multiplying by negative?
Because their answer didn't match our blue one.
So then wouldn't it be 3y equals that?
Oh, no. Good question. He's like, wait, why are we all eating lollipops and you're not, Lombo? Tell me this. Let's say x equals 2/9. Is that the same as 6/27?
Yes.
You know what I'm saying? When you multiply everything by that same factor, it's just like, oh, I ate 2/4 of my pizza. Well, you actually ate a half of it. Yep. Good question, Nels. Is that answer E? D. Word. We're on page 11 at the top. Give this one a shot. When it's like that, I agree, we can cross multiply. Go give it a shot. Maybe check in periodically and let's see how we do.
Did we do this problem with different numbers?
Kinda. It's very similar.
I think it was the same numbers.
Yeah.
Is it the same problem?
It should be.
Let's save our time because we'll practice this still. What makes it C as opposed to D, you guys?
Negative.
Yeah, silly me. It's going to be C. Let's just save our time. Good call, Seamus. Thank you. Let's go to this guy. Ooh, we just increased difficulty. This is good. I'm here for it. Okay. Whew, look at this. I gave you the point breakdown. This is 6 points of the 9-point free response, just part C. Let's go talk through what does separating the variables look like in this case?
Okay, so
How am I going to get rid of this? We haven't seen one this hard yet.
divide this.
Divide by y minus 1.
Agreed. Divide by y minus 1 is going to look like what? 1 over y minus 1 dy. And say that again, buddy. He said, let's go move that dx over as well. When I do that, call, let's also move this thing up. You with me, Stevie? Let's go move that thing up. So it would become 1 minus 2. Yeah, and I haven't done any calculus yet, but I know that that's going to help me. This is going to be the hardest step that we've come across yet. We need antiderivatives. So check this out. You just got 1 point by separating the variables. They're saying if you don't separate the variables, you will get 0 of the 6 points available. Whoa. We want to get at least 1 6. 2 points come from my antiderivatives. Let's just look at the right side. Antiderivative of 1. Good. Antiderivative of negative 2x to the negative second. 2x to the
Negative first.
negative 1 over negative 1. Instead of saying over negative 1, boom.
2 over x.
Ooh, plus 2 over x. I love that. So you're saying x plus 2 over x.
Plus c.
Beautiful. Very good. You just got 1 point for an antiderivative. There's 2. The reason they're giving us 2 here is because this one's a hard one.
We get y minus 1 to the negative.
Okay. He said, what if we did this? Don't write this down. Because guess what? What happens when I add 1 to that exponent?
It makes it 0.
It would be y minus 1 to the 0 over.
0.
That's a problem.
So it's canceled.
No. You guys, what's this?
LN.
Yes.
No.
Yes. So is this also going to be an ln? Yes. So this is why they know that this is hard. That's why they're giving you a whole point for just the left side. So this is going to be an ln of y minus 1. Now, you might be like, wait, why didn't that work? Nelson, I'm so glad you brought that up. Because when I add 1 to that exponent and divide by my new exponent, we'd be to 0 over 0. It's just like this one too.
Well, then aren't those technically equivalent?
Yeah.
ln of y minus 1.
Yeah. Isn't this y to the negative 1 there? And wouldn't that become y to the 0 over 0? So that's how I kind of am glad that it doesn't work out to remind us like, oh yeah, we got to go ln.
Anytime that happens, can you just go assume it's ln?
Yes. Now, what do we need to make sure for us to assume? There can be, the derivative of the inner always has to be only 1. Meaning, what's the derivative of this? 1 over y minus 1 times the derivative of the inner. What's the derivative of y? Exactly.
If it were 2y, then
It'd be a u sub. Exactly. Or if it was a 2y, what could we do instead of doing u sub?
Divide by 2.
So it would be what in front of my natural log? 1/2. Guys, that's good, that's good, that's good. That's so good. Okay, so you guys, let's go plug in our point now. ln of y minus 1. Okay, let's go plug in our point. My y is what? My x is?
1.
Beautiful. So when we have ln of 1, which is 0, she says. My x is 1. ln of 1, they need us to know that. It's 0 every time.
Negative 3.
Yeah. You guys, you just got 2 points for the antiderivatives. That was hard. You found the C by using the initial condition. Plugging in that point gets you a point. Now if we just go get my y by itself, then we're done. So I'm going to go plug in negative 3 for C there. Oh, this is going to be uncomfortable, people. This is going to be uncomfortable. You guys, does anyone remember how we'd get my y by itself here? Yeah, we got to e it. You guys, what's an e to the natural log? Boop. They cancel out. And I'm left with my y minus 1. Does anyone remember from yesterday what we got to do to get rid of those bars? Yes, we got a plus or minus. So just a reminder. Do you guys agree the absolute value of 4 is 4? Yeah. And the absolute value of negative 4 is 4? Yeah. So whenever we have these absolute value bars, just plus or minus this side, and we are taking care of it being a positive or negative. We have e to all of that stuff.
And then add 1.
And then add 1. They said solve for y. Get y by itself. So I got 1 minus e to the x plus 2 over x minus 3. Now, fun fact. Fun fact. Do we actually need Plinus in this case?
you just need the plus.
We just need the plus because my y needs to be a positive 2. Sure. So you're saying my answer could have been, should have been 1 plus that, or positive e to the x plus 2 over x minus 3, and then throw a plus 1 at the end.
If there was a plus or minus, would we just have to specify plus 1, or would we have to do parentheses or something?
Nope, we're all good.
Okay.
Yeah, just make sure that plus 1 is not in your exponent. Okay, top one. This is the last one I'm doing for you. No, you got this. Let's separate those variables. Ooh. But if I cross multiplied, I'd still have a y.
Fine. Just do it.
Cross multiply then divide by 1.
What's the better way to?
But wait,
They're more complicated.
wait. Couldn't we just multiply by dx first?
Okay.
So we have dy equals. Now, bear with me. Would you agree x over 4 times y minus 1 dx? This is still the same. I just stretched it out.
Y minus 1.
No,
So the
dude.
over, under,
It could-
under that.
Well, it's all being multiplied together, so I could say like that times that is still what I started with, right? If we multiply it, don't I still get what I started with?
Yeah.
So that might help us see, how am I getting rid of this? Yeah, so what would that John look like over here?
1 over
Yeah, 1 over.
y minus 1.
Uh-huh.
X over 4 dx.
Exactly. This is the last one, guys. This is the last one, I promise. I often lie about that, but for real, I'm being for realsies.
Integrate it.
Integrate it.
ln of y minus 1.
ln of y minus 1
Oh.
would become x to the blank over blank.
So it's 1/4 x squared.
It's very kind of him.
X to the second over 8 plus.
C.
Beautiful. Okay.
Okay, so let's say
Plug in y.
Yeah, if my y is a 3, we'd have the ln of 2. You guys, can I get rid of the bars? The 2 is already positive, right? 3 minus 1 is 2. Okay. Equals x. Oop, what's my x? So we're saying 1/8. So this might be ugly. Don't make it, just leave it. It'd be ln of 2 minus 1/8 is my C. We're good. Thank you.
So,
I gotta plug it back in.
E.
I'm gonna write it, substitute it in, then I'm gonna E it. I agree. Natural log, y minus 1 equals x squared over 8 plus an ln of 2, thanks to Colin for that, minus an 1/8.
E.
E it. Boop, boop. So you guys, that E in the natural log, they gone. To Lila's point, hey Li, you know when I want to get rid of these absolute value bars? And to do that, I'd have a plus or minus. Lila, look at this point. Do I want it to be a plus or minus based on this Y value? Exactly. So I don't have to worry about the plus or minus. I can just do a positive E. You guys okay with that?
The thing in the exponent, it's not gonna mess with the ln of 2.
Correct. Oh, actually, I'm going to show you. Good call. That's a really good point. That's why I chose this problem.
Choose to leave the plus or minus.
No, you cannot choose because in this case, it has to be positive. It can't be negative. You guys, if we need to get sorry, Sammy, yeah. So, would you guys agree? I can add my 1 over, and I could have 1 plus E to all of that. We are good right there. You're done. Or Mr. Nelson's throwing his 1 at the end. That's fine. Their answer might be written differently, meaning if this was free response, we're done. I just want you to know, do you guys agree right here, when we had an E to the natural log, they canceled out. And we were just left with a Y minus 1. Do you agree we have a little E to the natural log there? So I'm going to just show you something. This is equivalent to 1 plus E to the x squared over 8 times E to the ln of 2 times E to the negative 1/8. And you're like, what? Let's think about this real fast. What if I said, what's x squared times x to the 5th?
X to the 7.
Yeah, isn't it really x to the 2nd plus 5, which is x to the 7th? So is this equivalent to that? I just broke that down. So what does this get me?
E to X.
This gets me a 2 that I could bring out front. This gets me a 2 right there. So we could say that's 1 plus 2 e to the x squared over 8 minus an 8th.
The reason we didn't do plus or minus is because both points are positive. We don't have to worry about it.
Because my y value is positive right there. It doesn't have to do with the x, just that y value. So I'm just letting you know their multiple choice answer would take that 2 and they're going to put it right, that 2 and they're going to put it right there.